All right, I'm going to get started. If people file in, that's cool. There's a bunch of stuff to get through. So thanks for coming. This is the deep dive session for the Open Policy Agent project. I'm Torin. I'm one of the co-founders of the project and one of the core contributors to it today. I'm also an engineer at Styra. Styra is one of the companies that supports the project. I'm based in SF, and so if you want to meet up or something like that and talk about policy or authorization or OPA, feel free to just reach out to me. That's my Twitter handle. You can get a hold of me there. The Unicode for the Canadian flag and the rain droplet didn't seem to show up properly, but I'm happy to be in Seattle and see some rain for once because there are no seasons in the Bay Area. So anyway, what I'm going to do today is kind of jump into how OPA works. And to do that, what I want to do is just set up a little bit of an example. So this is like a hypothetical architecture for an online retailer that sells pet supplies or things like dog food to people over the internet. And so there are kind of two personas that are involved in this. So there's Bob. He's a customer. He likes to log into pets.com and purchase dog food and cat food and so on. And then there's Alice, and Alice is a customer service rep. She kind of answers questions that Bob has, and she also debugs problems in the system when Bob can't order pet food. And so we've built this backend for pets.com following a microservice architecture. So we have a service that handles payments and a service that handles user accounts and promotions and notifications and all these things. And we run our own database. We run Postgres for account data and promotion data. And we also leverage some cloud services like S3 and notification services and so on. And so sometimes Alice has to access these services to figure out what's going on and to handle customer queries. And the problem with that is that today she has full access in the system, right? So she can just open up her terminal and start executing API requests against payments or accounts and whatnot. There's like no protection in place. They do authenticate those requests. They do check that Alice is who she says she is, but there are no controls over what Alice can actually do in the system. And so this is not great, right? Like if Alice gets disgruntled and she decides to take down the payment service, then we're no longer selling pet food online and our customers are unhappy. Also, if she decides to look up where Bob lives, she can just do that. She can go into the pet detail or the account service and find out all of his personally identifiable information. Right? Again, this is not ideal. So what we want to do is kind of put some guardrails into the system to prevent these kinds of things from happening, right? So this is like an example of a policy that people might want to enforce, right? They want to say that support staff can view customer data if they're assigned to an open ticket for that customer, right? So this helps us put some guardrail in place that, Alice can still do her job, she can still support Bob, but she can't, do anything, right? So we've got a little bit of protection in place. Now, in order to do that, what we have to do is go into all of these different components, these parts of the system, these services, and basically implement authorization, right? We need to write code that checks whether Alice should be able to do the thing she's asking to do. And so you might decide to do that by just writing code. You might go into the payment service, which is written in Python, and add the check there, and the account service that's written in Java, and add the check there, and so on and so forth, right? The problem with that approach is that it raises a number of questions, right? So what happens when the policy changes, right? What happens when InfoSec or compliance or the legal department comes along and they say, now you have to check the geographic region that Alice is connecting from, or you need to check the device that she's connecting on, or you need to do something based on the current time of day, like she shouldn't be looking at Bob's account outside of work hours, right? So how do you handle those kinds of changes to the policy? Moreover, what happens if Bob says that he wants to have some kind of control over the permissions that are granted to his data, right? How do you delegate control over the policy to your end users? How do you roll out policy changes when they need to get updated? How do you leverage external context? How do you pull in data from an external data source like a ticketing system or PagerDuty or AD and so on, right? But then there are even more fundamental problems. So for example, how do you test that your policies are actually implemented correctly? Right? If you have hundreds of services written in dozens of languages using all kinds of different protocols running in containers and VMs and bare metal and serverless and whatever, how do you actually know that you've implemented this policy correctly across this wide range of technology? And so these are some of the problems that we set out to help solve when we started the project. So the Open Policy Agent, or OPA as we call it, is a policy engine. And what that means is that you can take OPA and you can use it to help unify policy enforcement across a wide range of technology. So the goal of the project is to unify policy enforcement in any service, in any system, at any layer of the stack. And so we started the project in 2016, and today, 3 years later, we have quite a few people using the project. Companies like Netflix, Chef, Medallia, State Street, Intuit, and Capital One talked yesterday at the intro session about how they're doing admission control in Kubernetes with OPA. And so we have all these companies using OPA for a variety of different use cases like admission control, API authorization with ACLs and role-based access control and IAM and ABAC, as well as other use cases like risk management on infrastructure, data protection, and more. So how does OPA actually work? How do we achieve all of this? Well, at the core of OPA, there's this idea that policy decision making should be decoupled from policy enforcement. Okay, so if we were going to go build the account service, we would have to implement an API, right, that allows people to view user account information. And so if you wanted to look up the account information for Bob, you would do a get on /accounts/Bob, and then you provide your credentials. Now, when that request comes into the account service, it has to make a decision about whether or not to allow or deny the request. And so when you use OPA, what you're doing is you're offloading that decision-making process to OPA, or to a dedicated engine. And so the way this works is that the account service would execute a query, and in that query, it would supply a bunch of attributes. So it's going to supply things like the method and the path and the authenticated user that's making the request. And then OPA is going to take those attributes and it's going to evaluate them against the policy and the data that it has access to in order to produce a decision, like allow or deny, which here we've represented as true or false. And then that decision gets sent back to the service in the response, and the service can enforce it. So if it was an allow, it would continue processing the request normally. If it was a deny, then it would reject the request. Right? So this is it. This is at the fundamental level. This is what OPA is helping you do. Now, it's important to keep in mind here that the service can be any number of different kinds of services or components or parts of the stack, right? So it could be a container orchestrator like Kubernetes. It could be an API gateway like Kong. It could be Istio, Envoy. It could be Linux PAM at the host level, right? Protecting SSH and sudo access on the machines. Or it could be something around a message broker or a database or something like that, right? So these are actually all examples of projects and services that we have integrations with today. Now, that's why we call it general purpose. Now, in order to make that happen, in order to realize this goal, we made certain design decisions when we started the project. And one of the fundamental design decisions was that the attributes that you provide to OPA can actually be arbitrary JSON data. So you can provide arbitrary or any JSON value to OPA when you execute a policy query. Similarly, the decisions that OPA generates can be arbitrary or you can generate any JSON value from your policies. Okay? So in a simple authorization case, you might generate, allow or deny and represent that as true or false. But in like an admission control use case, you might need to generate like a complex structured object that represents the admission webhook response. Now, obviously, the policy needs to be able to apply meaning to the input, the attributes that are coming in. It needs to know that that input is a pod spec or a deployment or an API or attributes representing an API request. And similarly, the service needs to know how to interpret the result, meaning like true maps to allow and false maps to deny. But on its own, OPA doesn't really care. All it sees is JSON coming in, JSON being evaluated, and JSON going back. Okay, so let's take a look at how we would actually implement one of these policies for pets.com. So what we want to do is say that users should be allowed to view their own accounts. And secondly, that support should be allowed to view accounts if they're assigned to an open ticket on that account. Okay, so what I'm going to do here is switch over to my VS Code IDE. And I have a policy here that I've written in OPA's policy language. So this is an example of a policy written in Rego, which is a purpose-built declarative language for answering the kinds of questions that you have to address all the time when you're working with policy. So it's really good at answering questions like, can this user perform this action on this resource? And so in this case, we basically created two rules to codify that high-level policy. So the first rule basically allows customers to access their own accounts. And the second rule allows support to access the accounts of customers that they're assisting. So the way that you can kind of understand this first rule is as follows. So allow is true if input method matches get, and input path matches accounts username, and input subject user matches username. So in order for allow to be true, all of the statements in the body need to be true, okay? So OPA is going to basically AND those expressions together in order to decide whether or not the request should be allowed. The second rule is similar. It says allow is true if input method matches get, and input path matches accounts username, and input subject groups contains customer service, And input subject user matches tickets of username of underscore of assignee. So again, the statements and the bodies of the rules get ANDed together. And then in this case, if either of the allow rules were true, then the request would be allowed. If neither of them matched, then the request would be denied. Now there are a couple interesting things going on inside of this policy, and I'm going to kind of dive into them. So the first thing that's kind of interesting is this last line in the second rule. Input subject user must match tickets of username of underscore of assignee. In this case, what that's doing is it's looking up context that would be cached inside of OPA that represents the open tickets in the system. And so I've got some data here, some JSON data. And this would just basically be loaded into OPA. So you can see it's just JSON. It's organized hierarchically. It basically sets up a mapping of users to open tickets for those users. So here in this case, Bob has 2 open tickets. One is assigned to Alice. The other is assigned to Karen. And then Janet has 1 open ticket, which is assigned to Karen. So in this case, Karen can basically access her own account as well as the accounts of Bob and Janet. And then Alice is only allowed to access her own account and Bob's account. Okay? Now, one of the nice things about OPA's policy language is that because it's written in this declarative fashion, you can actually just query it and you can dry run it and you can ask questions of it in your development environment. So for example, right now I can just select the allow rule and evaluate that, and right now it's true. The reason why it's true is because I've set up some input data to use. And so right now I have basically a request for Bob's account on behalf of Bob, right? And so allow should obviously be true. If I change the user to Alice and I rerun that query, now the decision is false, right? She should not, wait, oops, yeah, wait a second. That's not what I was expecting. Oh, right, because I don't have the customer service group on our subject. Okay, that makes sense, good. But you can also select other parts of the policy. So you can actually select just arbitrary parts here. So if I select data pet store tickets and I evaluate that, you can see that it just produces the value that OPA would see when it's evaluating the policy. Now, you can go even further than that. So I can actually just select parts of this rule. I can select the first expression in the first rule and evaluate that. And sure enough, the answer is true because the input method is get. But I can also select the entire rule body or even just subsets of it. Now what's interesting in this case is that we've got this username variable inside of the rule body. And so what happens when OPA evaluates these rules is it is trying to find values for the variables that make the statements true. Okay, so when OPA evaluates this rule, it's going to bind username to a value that makes all of the expressions in the body true. And so if we evaluate this right now, just the first 2 lines, you can see that the username is bound to Bob, right? Because that's what was in the path. But if we go and we try to evaluate this last line here as well, there are no results, right? And so the reason why there are no results is because the subject user is Alice. And that does not equal the username, right? So there's no way that OPA can find a way to prove that allow should be true. If I go back and I switch this to Bob, and I reevaluate, again, all 3 statements are true, and that's why it would be allowed. Okay, so how do you actually integrate with OPA, right? This is great, this is like a development environment, but how do you actually use OPA? So let me dive in here and make sure this is the right terminal, which it's not. Okay, what I have here is a simple program written in Go, and I'm going to show how you can kind of integrate OPA as a library. So if I run this program right now, it's just waiting for, actually it's going to complain. It's going to say that it needs some bundle. And in OPA, we have this concept of a bundle. It's basically just a gzip tarball that contains these policy files and these JSON data files. And so I can just create that bundle that it needs on the command line by passing in the data and the policy. And now if I run this and I pass in the bundle, it's going to wait for input. Okay, so it's waiting for me to give it some input. And so if I just type garbage, it's going to complain that it's not valid JSON. But if I give it like the number 10, which is a valid JSON value, it's going to evaluate the policy with the number 10 assigned to input. And so obviously in that case, the policy decision is deny, right? There's no way that the number 10 can satisfy all of those constraints and those rules. But I actually have some other inputs here that are a little bit more interesting. So for example, this is an example of a request from Alice with the customer service group on her subject for Bob's account, right? So that should be allowed. And so if I run this, I can just go run main, pass in the bundle, and then pass in that over standard in, right? And so sure enough, that gets allowed. But I also have a case that would get denied here, right? So this is a request from Alice for Janet's account, right? She's not assigned a ticket for Janet. And in this case, it's missing the customer service group, so it would get denied for that reason as well. But just to drive the point home, in that case, it gets denied. So how does this actually work? Well, it's not that complicated, actually. So when you're embedding OPA as a library, what you're doing is you're interacting with this Rego package that it exposes. So Rego is the language, and it's the high-level API that you use to evaluate policies. And so what this program is going to do is it's going to load the bundle off disk. It's going to instantiate OPA's compiler and storage layer. These are like data structures that are used during the evaluation process. And then it's going to decode the input that I provided over standard in. And then it's going to construct this Rego object that's going to get used for evaluation. And so when you construct the Rego object, you pass in things like the compiler and the store and the input. And then you also provide the query that you want to run. So in this case, we're asking for the value of allow, and we're binding it to a variable called allowed. Now, there are other inputs that you can provide. You can provide things for like tracing and profiling and metrics and so on, and instrumentation. But in this case, we're just basically providing the core necessities. And so then you run evaluation, and you interpret the result. And so in this case, if there were no results, if the policy decision was undefined, we would just bail out. We would say there's an error. The reason for that is because in this case, we've said that the default value for allow is false, right? So if there's no other value that's coming back from one of these rules, it should use false. It should send back false. And so if there are no answers coming back, then that's an error. You'd reply with like a 500 or something like that. But otherwise, you just look at the value of the allowed variable. And so if it's true, you interpret that as allow. If it's false, you interpret that as deny. Okay, now, one of the things that comes up when you start working with these policies is that you can end up with more than 2 rules, obviously. You can end up with tens or hundreds of rules, and some of those rules might be complicated, and so you don't really want to be manually querying the policy to understand whether it's correct. And so what we have in OPA to help you verify that your policies are correct is a unit testing framework. So you can actually write unit tests for your policies, and this is what they look like. So you create a rule called test, and in this case, a rule that starts with the name test. And I'm going to create 2 cases here, a positive test and a negative test. And so I'm going to check that Bob is allowed to access his own account, and Alice is allowed to access accounts if she's in customer service and assigned a ticket. And then I'm going to test the opposites, right, that you don't have full access or whatever. And then you can just run these inside of, on the command line or inside of tools like VS Code. And so if I run these tests, getting an error here. Oh, it's complaining about the fact that I've got duplicates because I had that bundle created. So if I run that again, you can see that the tests are passing right now, which is great. But you can go further than that. You can actually tell what parts of your policy are being hit by these tests. So if you run, you can compute the coverage and have that visualized. This is telling me that basically the tests themselves are being covered because they're being executed. But if we look at our example policy here, again, all of the parts of the policy are being hit, right? So we've exercised all of these cases. If I go back into the policy and say I disable the part that's based on context, based on the tickets, and I save that and rerun it, now you can see that we're never actually exercising the second rule fully, right? So we never made it to the last line in the policy. Right? So with OPA, you can use the policies in different ways, right? You can obviously use them at enforcement time, but you can also dry run them, you can write tests for them, and you can query them in different ways to audit and to debug and so on. Okay. So what I want to do also here is talk about some of the new use cases and features that we've been working on in OPA. So I will kind of give a caveat here that these are still in early stages of development. They're sort of at an alpha stage, but they're usable. You can try them out, and we're looking for feedback on these features and these use cases. So the first use case that we started looking into earlier this year is around data filtering. So suppose that the pets.com business is doing great, and we want to expand to help you, keep track of your pets, right, and keep track of their health. Right? So we create a service that stores health information on your pets. And we also have a staff of veterinarians that can kind of like, treat your pets and do diagnosis and so on. And so what we're going to do is build a service that keeps track of all that information. And it's going to expose an API that allows you to get access to that data. And it's going to store that data in a SQL database, right? So whenever you ask for the pets that you should see, the pet details service is going to go and execute a query against its database. It's going to select star from pets, and that's going to return a bunch of records that ultimately go back via the API. And so the question becomes, what if we want to enforce a policy that says that veterinarians are only allowed to see the details of pets that they're treating? Right? That information about which veterinarians are treating which pets is not contained in the request, right? So it's not readily available when the pet details service would execute the policy query, right? We could change the pet details service to call out to the database and get the data and then pass it in the input. Or we could try to replicate the data from the database into OPA. But when you start doing that at a large scale, you're going to find that there are certain challenges around performance and scalability that are hard to overcome. You're going to find that it's difficult to maintain and that it violates certain consistency guarantees you might expect from the system. So what are we going to do? Well, we're probably going to just go and do this in our application, right? We're going to stick a where clause onto that query that's going to filter the results for us. And then we could just declare a job done. Except the problem is that at this point, the logic that decides whether or not you're allowed to see a row in the database is now hard-coded into the pet details service, right? And so if we want to change this policy in any way, we have to go into that service and understand it at a very fundamental level in order to do anything. And so what you'd really want to be able to do is control that query that's running through policy, right? Because that way we don't have to replicate all the data into OPA. We can avoid the performance and the scalability bottlenecks that are inherent in that. And we don't have to worry so much about the maintainability and the correctness over time. So I've got a little demo about this that shows how this works. So for example, this is a little sample app that we have. It's the sample app for the pet clinic that pet.com is trialing. And so you can see that right now we're logged in, but we can see, or we're not logged in rather, and we can see all the pets, right? So we can see Bob's pets and Liz's pets and John's pet and so on. And even if we log in right now, it doesn't really change anything. We're logged in as Bob and we can see everything. The reason why that's the case is because the policy here hasn't put any constraints over the data that can be returned to the user. It's just saying that basically any pet can be returned to any user. And so if we wanted to restrict this return value to say that you can only see pets that you own, we would add a condition into this policy. So we would say that the clinic for the pet must match, or rather the owner of the pet must match the user in the request. And now if we refresh the page, you can see that we're only seeing the pets for Bob, right? And so if we go in and we log in as Liz, we see her pets. If we log in as John, we see his pets. Okay, so this is a super simple example of a policy that just says that you should be allowed to see the pets that you own. But what about the veterinarians, right? If I log in as Alice here, she can't see anything. And so in order to give Alice access to the data, what we're going to do is add another rule. So we're going to say that data pets can be displayed if the pet veterinarian, hopefully I can spell this correctly, is equal to the subject user. And now, if I save that and refresh, you can see that Alice is able to see the pets that she's treating. Similarly, Terry, the other veterinarian, is able to see the pets that she's treating, right? But what if we want to go further than this? What if we want to say that you should only be able to see pets that you're treating at the clinic that you're working at, right? Well, you just extend the policy with another condition that says that the pet clinic must be equal to the location that was determined when the user authenticated, for example, right? And so now, if we sign back in as Alice, she can only see the pets at Shady Bluffs, where she's currently signed in. Okay, so that's data filtering with OPA. The way this works is slightly different from the other examples that I showed. So when the pet detail service receives the incoming API request, it still queries OPA. It still supplies a bunch of attributes. But now instead of replying with just simply true or false, what OPA does is it evaluates the policy with certain unknowns in account. So for example, the pets data would be treated as unknown. And then any conditions that depend on those unknowns get returned back to the pet details service so that they can be applied to the request processing later in the chain. And so in this case, if Bob was accessing his pets, then he would, we'd generate this condition that says pets.owner must be equal to Bob. So this is a quick example of how this works. We have a blog for the project. There's a post on there called Write Policy in OPA, Enforce Policy in SQL. If you're interested in these kind of data filtering use cases, I recommend that you take a look at that. And if you have ideas about how this could be used, or you have feedback, we'd love to hear it and we'd love to talk with you. Okay, the last thing that I want to talk about is something that I'm super excited about, which is OPA and WebAssembly. So I don't know how many people here are familiar with WebAssembly, but I'll just give a kind of a really quick overview. So WebAssembly is basically a binary instruction format for building stack-based virtual machines. So just like x86 assembly exists and you can compile C and C++ down to x86 and run it natively, you can compile C, C++, Rust, and Go, and a bunch of other languages down to WebAssembly, and then run that code in a WebAssembly VM in the browser or elsewhere. And so today, WebAssembly is supported in the major browsers, and it's getting a lot of traction outside of the browser ecosystem as well because it has certain properties that make it very good for extensibility use cases. Whenever you need to kind of implement plugins or implement some kind of extensibility, WebAssembly has certain properties around memory safety and efficiency in terms of the size of the binaries, and the fact that it's being kind of defined by a large number of organizations makes it kind of this open platform. And so there are all these non-web embeddings that they call the so-called non-web embeddings, like IoT and desktop and servers and even blockchain. But what I'm mainly interested in is how WebAssembly can be applied to this problem of policy enforcement and servers and data centers and so on. So what does WebAssembly have to do with OPA? Well, over the last 3 years, we've found certain things after talking to a large number of people that are using OPA. And one of those things is that library integrations can often be a lot simpler, right? As opposed to having to stand up a separate daemon in the system, the library integrations have a little bit more control with the library integration. There's less overhead, there's fewer context switches, there's less copies happening, so it's more performant. There's a little bit less operational complexity. You don't have to worry about securing this daemon that's running on every machine. You don't have to necessarily worry about monitoring and so on, or as much. So having the ability to evaluate OPA policies via a library integration is compelling for a lot of people. And WebAssembly will make this possible because today OPA is written in Go, so it's only really embeddable as a library in Go applications. But with WebAssembly runtimes popping up in Go and Rust and obviously V8 and other popular engines, it's likely that you'll be able to embed WebAssembly in any language in the near future. The other aspect is that some platforms are unlikely to necessarily embed OPA runtimes, but they are likely to embed WebAssembly runtimes. So for example, Cloudflare recently announced that they would support WebAssembly executables on their workers. So you can take WebAssembly, you can compile code down to WebAssembly and then distribute it out to the edge, to the points of presence that Cloudflare has, and have it run very close to your customers, right? Envoy, the service proxy, is also considering adding WebAssembly support to the service proxy, right? And so I think that WebAssembly is it's super interesting, and it kind of might help answer this question of how do I enforce policies in a serverless or edge computing environment. And so we actually have an initial version of this working today. You can compile down a fragment of the language today, and so oops. On the right terminal, yep. So it's a simple fragment of the language, but basic ACLs you can compile down, basic forms of iteration can get compiled down, and we're going to kind of flesh this out in the next few months. But here I've got a simple policy that is basically implementing an access control list effectively on a HTTP API. And what I can do now is I can compile this down into WebAssembly. So I'm going to pass in the policy, and I'm going to pass in a query to run. In this case, I want to check whether allow is true. And what that's going to do is emit a WebAssembly binary. So you can see it's just created this policy.wasm file on disk. And now I can load that up into a Node.js app. So I have this Node app here. And if I run this with like the value 1, it's going to basically load the policy off disk, initialize the WebAssembly address space, and then evaluate the policy. And in this case, the value 1 gets denied. But if I pass in the value, get and path trades, that should be allowed, right? But similarly, if I try to post and I'm not an admin, then I'll be denied, right? So I think this is super cool because the integration is really simple for the app, right? So there's a bit of boilerplate here, just ignore that. Basically, the way this works is that you instantiate the WebAssembly address space. You can give it a size. You can put a bound on the actual amount of memory that the policy evaluation can consume. And then you load the policy off disk or off the wire and evaluate it, right? And so here I'm just parsing the JSON input and then interpreting the output. There's not too much interesting about the actual evaluation. There's a little bit of setup that has to happen on the address space. But after that, it's pretty straightforward. So this is obviously proof of concept. We would probably wrap this in an SDK or something like that, or a library that provides a little bit of a higher level interface, but this gives you a sense of how this works. Cool. So that's it. Thank you very much. If you're interested in the project, check out the Slack organization. We have about 450 people on there. Check it out on GitHub. Star the project. We love more stars. I'm going to push all of the code from this talk up to GitHub later today. And if you're interested in contributing, please come say hello. I'd love to chat. If you want to contribute integrations or tooling or work on the core part of the language, I'd love to chat with you. We also have tickets that are assigned or that have labels like low-hanging fruit that are super easy to get started with, or help wanted. Some of those are a little bit bigger, but yeah, thank you very much.